Hi students, if you have not watched the Unit 8 theory part, please go back and watch those videos so that you can get some idea on how to solve the problems. Okay, let's move on to the questions. Question 8.4. Expand each of the following condensed formulas into their complete structural formulas. Okay, first we have to write the backbone as usual. How many carbons are there? 1, 2, 3, 4 and 5. Let's write the atoms. 1, 2, 3, 4 and 5. Okay, then let's start with the left end. You have 3 hydrogen atoms, then mark the 3. 1, 2, 3. Then you have 2 hydrogen atoms, mark 2 hydrogen atoms. 1 and 2. You have a oxygen atom, so you have to make a double bond here. Remember that carbon has to have 4 bonds. Okay, since I have already drawn here 2 bonds, I cannot write single bond here. Okay, I have to write double bond here. Okay, so after this we have a carbon and we have 2 hydrogen atoms here, 1 and 2, and at the right end we have 3 hydrogen atoms, right? 1, 2, 3. This is the complete structure. Okay, this is how you can write the complete structure for this compound. Let's go to the next question. This one, how many carbons are there? 1, 2, 3, and you see here it's a thrice. Do not get confused, it's a thrice. I will explain you how to write this one. Okay, so 1, 2, 3, 3 plus 3 6 and 7 carbon atoms are there. The beauty is that it's not a branched chain, it's a continuous one. Okay, so we have to write all the 7 atoms in a row. 1, 2, 3, 4, 5, 6 and 7. Then you start from the left hand. There are 3 hydrogens, right? 1, 2, 3, and there is 1 hydrogen. You see here there is a double bond. I have already written 1 bond. When I make a double bond, this means that this carbon has 4 bonds. So condition is satisfied. You have to check whether all the carbons are having 4 bonds. It could be pi bond, it could be sigma bond, no issues at all, but the carbon should have 4 bonds. If it is not having 4 bonds, that means your structure is not correct. Okay, now can you tell me how many atoms will be placed on this carbon atom? We already have double bond here, we already have a single bond here, so how many atoms, hydrogen atoms are possible? Only one, right? So that's why they give only one hydrogen atom. Okay, then CH2 thrice. So I have 1, 2, 3, and the last one is on the right side. So how many hydrogens are there? 2 hydrogens are there on each of the carbons. 1, 2, 1, 2, 1, 2, and at the end there are 3 hydrogen atoms. Okay, this is how we write the complete structures of the molecules. Okay, so let's move on to the next question. For each of the following compounds, write a condensed formula and also their bond line formula. Okay, they asked here to write the condensed formula also. Okay, let's look at the first one. Okay, for this structure, how to write the condensed formula. Okay, check how many carbon atoms are there. 1, 2, 3, 4, 5, 6, 7, 8. Okay, check how many carbons are having same number of hydrogens. Remember this rule. Check how many carbons are having same number of hydrogen atoms. I will mark in a different color so that you can understand, right? See here, it has 2 hydrogen, it has 2 hydrogen, it has 2 hydrogen, right? So that means it's a thrice. Am I right? It is a thrice. The last sum also we have seen such example, right? So let me write the structure like this. um, I will write the OH without any disturbance, then I will open a bracket, then I will write CH2. There are three CH2, so I will write thrice. Then I will write CH, right? And then how we will write? Is there any repetition? Is there any repetition? Here no repetition, here no repetition, here no repetition, but here CH3, CH3, it's a twice, right? So after this CH, I will write the CH3 followed by CH, then these two CH3 twice. I think you can understand, right? So first you check how many carbon atoms are there, then check how many carbons are having same number of hydrogen atoms. Okay, then you count on them and make them as a short form. Okay, this is a condensed formula. Now let's try to write the uh, bond length formula for this one. Okay, how to write the bond length formula this one? So for bond length formula, we know that if you write a dash, it means there are two methyl groups, right? And we can indicate other bonds also, right? So let's look at how to draw the structured condensed formula for this one. Again, we have to count the number of atoms. Okay, carbon atoms. How many are there? 1, 2, 3, 4, and then this one becomes a branched chain. Okay, 5, and then 6. Here from the condensed formula also you can calculate. Okay, so you can imagine like there are 3 carbons in a linear chain. So let me put up 3, 1, 2, 3. Then I have a fourth one, 4, and then I have a branch. Okay, how to write the branch? Branch you can write like this. Okay, then fifth one, 5, and then there are 2. Okay, 2, how they will be there? 1, and then one more on this direction. Okay, and now what is left? OH is left. How you will write the OH? Draw this, draw a bond like this one, and you can calculate. So count the carbons again. Before you finish the writing, count the carbons. 1, 2, 3, 4, 5, 6, 7, 8, right? So 3, 4, 5, 6, 7 and 8. Am I right? So there are two methyl groups attached to a CH. Two methyl groups attached to a CH. Okay, and then there is one CH3 group attached to one CH. There is one methyl group attached to a CH. Then three methylene groups. CH2 means methylene. 1, 2, 3, right? And at the end there you have a OH group. Am I right? So you can write like this. And let's move on to the next structure. How to write the condensed structure for this one? Okay, so this can be easily written. In fact, if you look at the both ends, you have two CN in common, and both are attached to a single carbon. So you can write like this, right? Within a bracket you can write CN. Am I right? Twice. Then what is left? OH is left. Simply write OH. That's all. This is the condensed structure. Okay, now let's move on to the bond line structure. How to write the bond line structure? First, how many carbons are there? Okay, you have to check. We have 1, 2, 3. So if we have 3 carbons, how we will write? 3 carbons, we will write a triangle, right? Triangle like V shape, inverted V shape, right? Okay, Then what is over there above the central carbon? This is the central carbon. What is the functional group over the central carbon? OH. Let me draw the bond and then write the OH. Okay, and now write the N groups. You have a N. Okay, so you have to indicate it as a CN. Then here also you have to indicate as a CN. Okay, if it is CH3, then you don't need to write it here. Okay, you can simply write like this. If it is CH3, but it is a CN, so you have to write. You have to write. Don't forget to write. Okay, and here again, don't write like this. It is also not correct. Okay, you have to write like this. This is the bond line formula. Okay, let's move on to the next question. 8.6, expand each of the following bond line formulas to show the all the atoms including carbon and hydrogen. Okay, so this is simply a opposite question of the previous two, right? So they have given the bond line structure and asked you to write the condensed structures. Okay, so this should be easier for you by this time, right? So let's start with the first one. Yay. Okay, so what will be the structure? What will be the expanded or complete structure for the first one? So these corners have CH2 and these ends have CH3, right? And this kind of joints, triple joints has CH. Okay, how many triple joints are there? Triple joints in the sense three bonds. Okay, so let's write. I am writing from the top, CH2, CH2, and then CH2, and then there is a CH2, here is a CH2, here CH. Okay, and then here CH, here you have CH3, here you have CH3. Okay, you're getting the point, right? So whenever there is a there are four, I mean this kind of single point, it is nothing but the methyl group. If you have three bonds connected, that is nothing but the CH. If you have this kind of two bonds connected, that is a CH2. Okay, so let's write the expanded structure, complete structure for this one. What could be the structure? Very simple. Count the carbon numbers: 1, 2, 3, 4, 5, 6, 7, 8. So you have to write 8 carbons, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Check whether there are any double bonds. There are no double bonds. There are no triple bonds. There is no other functional group like OH or NH2. Okay, so all you have is simple hydrogen. Okay, then we understand that these ends are CH3. Okay, first you write these ends. Then we understand that when there is a two joins, that is a CH2. I think everything is a two joint. Okay, here also, here also, here also. So everything is a two hydrogen atom. Here one hydrogen, here one hydrogen. All right, that's all. That's the basic structure of this molecule, right? Let's move on to the next one. What is the chemical structure of this molecule? Let's count the carbon atoms as usual. The ends always have one carbon. 1, 2, 3, 4, and 5. Most of the times, students will count this corner altogether as a one carbon. No, the bond ends here, triple bond ends here, so you have to count one carbon here. So totally there are 5 carbons. So you have to write all the 5 carbons. 1, 2, 3, 4, 5. Okay. So now let's look at what are the different functional groups available in this one. Okay. So if you check, we have a one carbon, two carbon. On second carbon there is a OH. So first write the OH. Whenever you see double bond or any special functional groups, you have to write them first. Okay. Without writing them, do not go on to write the structures. Okay. And then here you have triple bond. What does that mean? There is one carbon here, one carbon here, so this is a triple bond. Okay, finished. And what could be the end here? This is nothing but CH, and this is a clear CH3, so I will write CH3 for this one. Okay, CH3. Okay, and now what is left over here? You can see here there is a hydrogen, right? Okay, and then what is left over here? You can see there is a CH2, and that's all, right? This is the structure of this molecule. Okay, let's move on to the next one, D. Here you see there are 4 free ends, which means that they are nothing but the CH3, right? And I have always said that when you see 3 connections, that is a CH, right? Very easy, right? So you have to write the central atoms. There are 2 central atoms, 1, 2, and we have branches like this, and they also have carbons. These ends have 3 hydrogens, right? So I will write CH3, 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 and CH3. Okay, now calculate the number of bonds attached to each carbon. Here, this carbon has 3 hydrogen and 1 carbon. Okay, that is satisfied. This carbon has 3 hydrogen and there is 1 bond, satisfied. Similarly for them also, for them also. But these 2 carbons are not satisfied because only 3 bonds are there. Then how to satisfy? There are no double bonds given in the structure also. Then how to satisfy? Simply insert a hydrogen. Now there are 4 bonds, right? So this is how you have to solve the structures. You should be able to go inside and out to find the complete structure from the condensed formula or bond line formula, or from the bond line formula to condensed structure. You should be able to find in all the ways, because again I'm telling you that this is a very fundamental useful for you to understand the organic chemistry. Okay, based on this knowledge only you can write the equations and mechanisms that are coming in the upcoming chapters and also in the class 12 syllabus, right? Thank you for watching. Let's meet in the next video.